Here, two paths of reasoning diverge. One path is straight, direct, and certain. The other curves, winding through doubt and discovery. Which will you choose? From the specific observations along this path, we draw a general conclusion. This is inductive reasoning. From a general principle, we can deduce a specific outcome. This is deductive reasoning.
Inductive reasoning begins with observation. We examine individual pieces. When pieces begin to connect, we recognize a pattern. From that pattern, we form a conjecture. Deductive reasoning begins with the whole image. We already know the rule. Given the rule, each piece has only one correct place. The conclusion is certain. Observe two different paths. On this side, we begin with separate pieces. On this side, we begin with the complete image. Inductive reasoning starts with observation. As pieces connect, a pattern emerges. From that pattern, we form a general idea. Deductive reasoning begins with a known rule. Because we see the whole picture, we know exactly where each piece belongs. Inductive reasoning moves from specific pieces to a general conclusion. Deductive reasoning moves from a general rule to a certain conclusion. Geometry, my dear grandson, is discovering God's creation by measuring the wonders of His earth. It is written, "Then the Lord answered Job out of the whirlwind and said, Who is this that darkens counsel by words without knowledge? Now gird up your loins like a man, and I will ask you, and you instruct me." Where were you when I laid the foundation of the earth? Tell me, if you have any understanding. Who set its measurement, since you know? Or who stretched the line on it? On what were its bases sunk, or who laid its cornerstone? When the morning stars sang together, and all the sons of God shouted for joy. For by Him all things were created, both in the heavens and on earth. For all things have been created through Him and for Him. He is before all things, and in Him all things hold together. Geometry, indeed, is discovering God's creation by measuring the wonders of His earth. Logic and reasoning is described in God's word. It is written, "Make me understand the way of your precepts, so I will meditate on your wonders." Geometry is discovering God's creation by measuring the wonders of His earth. These waves teach us resilience, my friend. Let the wind fill your sails and carry you forward. Geometry is like a game or puzzle. You learn the terms and rules to figure out the steps to solution. This requires logic and deductive reasoning. Logic is a mind properly disciplined, and deductive reasoning is, from what is known, what must be. Logic is a mind properly disciplined, and deductive reasoning is, from what is known, what must be. Logic is a mind properly disciplined, and deductive reasoning is, from what is known, what must be. In other words, logic is thinking clearly using rules. Deductive reasoning is using known facts to prove something specific. In other words, logic is thinking clearly using rules. Deductive reasoning is using known facts to prove something specific. In other words, logic is thinking clearly using rules. Deductive reasoning is using known facts to prove something specific. The sea calls to us, my friends. With courage and stars to guide us, we shall find our destiny.
In the shadowy corridors of unsolved mysteries, three legendary detectives step forward: Sherlock Holmes, Columbo, and Adrian Monk.
It's elementary, my dear Jaden. Each of these detectives are armed not with gadgets, but with logic sharp enough to cut through confusion.
Sherlock Holmes observes the smallest detail and declares, with calm precision, that when the facts are arranged correctly, the truth becomes elementary. Columbo shuffles in with a polite smile and one more question, gently untangling contradictions until the culprit practically solves the case for him.
Adrian Monk straightens a crooked picture frame, notices what everyone else missed, and proves that even chaos follows patterns if you look closely enough. Together, these three teach us that solving a mystery is much like solving a geometry proof.
We gather the clues, apply deductive reasoning step by step, present your findings clearly in the case file as undeniable proof.
Jaden, one more thing. We always show our work step by step. It's always gift, never a curse.
Elementary!
Jaden, inductive reasoning involves observation, seeing a pattern, and conjecture. To solve a mystery, Sherlock, Columbo, and Monk first search for the clues. It's all about observation, or as Sherlock would say,
the game is afoot. Come, Jaden, the game is afoot.
Second, like putting together a puzzle, our detectives see how the clues fit together into a pattern. And third, our detectives make an assumption that the pattern will hold. In geometry and logic, this is our conjecture or hypothesis, or as Sherlock Holmes would do. Of course, it was never the butler. It was that darn cat all along. Come, Jaden, we mustn't keep our culprit waiting. Inductive reasoning. Start with specific clues, spot patterns. Like mud on shoes, fast watch, pattern points to the suspect's lie. Crooked frames, inconsistency, scream the truth. Risky guess, but sparks the hunt. It's all about observation. Risky guess, but sparks the hunt. It's all about observation. Yes, Sherlock, Columbo, and Monk are right. Inductive reasoning starts with specific clues, spots patterns, and comes to a general conjecture. It's all about observation. Here is an example of inductive reasoning. I see that every cat purrs. Yes, that's observation, but we need more observation to determine a pattern, a general conjecture. It's all about observation. Risky guess, but sparks the hunt. It's all about observation.
Yes, right again. Inductive reasoning requires making observations, determining a pattern, and then assuming that the pattern will always hold. This is called a general conjecture. It's all about observation.
Gentlemen, we stand united. Indeed, our position is unassailable. And our resolve is absolute. Let us proceed with clarity. Our general conjecture is that all cats purr. But wait, I saw a wild palace cat of Central Asia that barks, not purrs. That is a counterexample. Yes, we have not yet come to a proof of our conjecture. Yes, Jaden, Monk's counterexample is an exception to the observations. That is all it takes, one exception, to prove that the conjecture is false. Gentlemen, we stand united. Indeed, our position is unassailable. And our resolve is absolute. Let us proceed with clarity. Our general conjecture is proven false. All cats do not purr. Correct, our general conjecture was for all cats. Just one counterexample proves our conjecture false. Now, Jaden, one counterexample is only used to prove a conjecture false. Gentlemen, if you cannot find a counterexample, like a barking cat, that does not prove our conjecture true. It's a gift and a curse. Jaden, logic is rare. Therefore, it is upon the logic that you should dwell. It is a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories instead of theories to suit facts. Imagine, my dear Jaden, a rogue so dim-witted that he fancied all supplementary angles must form a straight line and proved equally mistaken, and he tried to leap a river between two rooftops.
Sherlock said the scoundrel's conjecture was that all supplementary angles form a linear pair, meaning that they are adjacent, sharing a common vertex and common side, as well as adding up to 180 degrees. Sherlock said the scoundrel's conjecture was that all supplementary angles form a linear pair, meaning that they are adjacent, sharing a common vertex and common side, as well as adding up to 180 degrees.
Gentlemen, how do we prove this rogue's conjecture false? That is easy. Find a single counterexample. Yes, just one pair of angles adding up to 180 degrees that are not adjacent.
Sherlock said the scoundrel's conjecture was that all supplementary angles form a linear pair, meaning that they are adjacent, sharing a common vertex and common side, as well as adding up to 180 degrees.
Gentlemen, how do we prove this rogue's conjecture false? That is easy. Find a single counterexample. Yes, just one pair of angles adding up to 180 degrees that are not adjacent. Yes, Sherlock, Colombo, and Monk are right again. Inductive reasoning includes searching for a counterexample. It will prove your conjecture false. Jaden, remember, it can't find a counterexample
Yes, Mr. Lincoln.
that does not prove that your conjecture is true.
Conditional statements are either true or false. Conditional statements are either true or false.
To prove an if-then conditional statement is true, you must show that conclusion occurs for all cases. To prove an if-then conditional statement is true, you must show that conclusion occurs for all cases. To prove an if-then conditional statement is false, you only need one counterexample that shows the statement is false. That's the power of logic. One exception can shatter the hypothesis. To prove an if-then conditional statement is false, you only need one counterexample that shows the statement is false. That's the power of logic. One exception can shatter the hypothesis. To prove an if-then
It is my hypothesis that if a cat purrs, then all cats purr. It is my hypothesis that if a cat purrs, then all cats purr. In logic, we often use letters. Let P represent the hypothesis, the if part of a statement. And let Q represent the conclusion, the then part of the statement. Once the hypothesis and conclusion are identified, the testing of the conditional if-then statement is performed. Testing is represented by an arrow pointing from P to Q. In symbolic form, we write it this way: P arrow Q, P arrow Q. That is the structure of deduction.
The hypothesis is tested and points to the conclusion. If the hypothesis holds true, the conclusion must follow. P arrow Q.
Jaden, what is the difference between conjecture and hypothesis?
Mr. Lincoln, conjecture is believed true based on observations and patterns, but not proven.
I see. Precisely. A hypothesis, however, can be tested. How does that differ with hypothesis?
Hypothesis is the if part of a logic statement. It is assumed condition which needs to be tested.
A conjecture predicts from patterns. A hypothesis sets a condition for proof. One begins suspicion, the other structures logic. Jaden, can a conjecture be restated as an hypothesis?
Yes, for example, the statement, all triangles have 180-degree angles. It can be restated as if it is a triangle, then it has 180 degrees.
Jaden, in crime or in geometry, the path is the same. Observation, patterns, conjecture, hypothesis, testing, conclusion. Jaden, in crime or in geometry, the path is the same. Observation, patterns, conjecture, hypothesis, testing, conclusion.
A conjecture predicts from patterns. A hypothesis sets a condition for proof. One begins suspicion, the other structures logic.
The foundation of law is reason and evidence, not mere opinion.
So facts are the key.
Precisely. Build your cases on that, and justice follows. Jaden, every great mystery follows a path. Observation, patterns, conjecture, hypothesis, conclusion. Let us begin. First observation. Footprints.
Mud.
A torn glove.
Facts only. Whoa.
When details repeat, they form patterns. The same boot, the same stride.
I see. Patterns reveal the truth.
The dimensions must be precise. Observe. I see. Just a hair off, maybe? A hair that unravels everything. Exactly. We must account for every variable. One more thing. These marks are exactly 1 inch apart. These were all made on the night of Friday the 13th. Jaden, see how Sherlock, Columbo, and Monk gather details by observation. The crime and footprints were made the same hour of night. See how the puzzle pieces fit a pattern?
A conjecture is a statement formed from observed patterns.
Yes, but not yet proven. I suspect the same man returned each night.
Let us be off. We must now prove our conjecture.
Yes, suspicion, but not certainty. What did our heroes do first?
Like using a magnifying glass, they investigate every detail. Observation.
Right, my boy. Then what did detectives do?
Like putting together a puzzle, they saw a pattern for the crime.
Precisely, the fog is lifting. They now have a suspicion of who did the dirty deed.
Conjecture.
Suspicion, but not yet proven. Jaden, every great mystery follows a path. Observation, patterns, conjecture, hypothesis, conclusion. Let us begin.
This is inductive reasoning. Observation, seeing a pattern. Conjecture, assumed to be true until proven false by a counterexample.
A conjecture predicts from patterns. A hypothesis sets a condition for proof. One begins suspicion, the other structures logic. A conjecture is a suspicion drawn from patterns, but suspicion alone proves nothing. To test it, we must reshape it into a hypothesis. An hypothesis gives logical structure to a suspicion. It takes a belief and places it into an if-then form. If this is true, then that must follow. Jaden, our Lord once gave a simple test of truth. By this shall all men know you are my disciples, if you love one another. There is the condition, and there is the result. A hypothesis is the if part of the test. If you were at the docks at midnight, then you could not have been here. Now, we examine the evidence. The dock ledger shows no record of your arrival, and the harbor clock confirms the timeline. So the if fails. When the if condition proves false, the conclusion built upon it cannot stand.
This teaches a key logical rule. If the premise is false, the argument collapses.
The dock records contradict your claim. The timeline does not hold. The if condition fails, therefore the alibi is false. Sir, the facts don't leave you anywhere else to stand. The conclusion follows from the evidence.
Did his confession prove he was guilty?
No, Jaden. The confession did not prove it. The proof was already established when the evidence was tested. A confession may confirm the truth, but it does not create it. Truth exists independent of feelings. It is established by evidence and by sound reasoning. If the evidence had failed, his tears would not make him guilty. And if the evidence had proven him innocent, his sorrow would not condemn him. Reason must stand even before emotion speaks. Emotion may follow truth, but it must never replace it. That is why we test our conjectures. That is why we examine our hypotheses, so that our conclusions rest on something firmer than feeling. A just mind does not bend to tears. It bends only to truth. And that, Jaden, is why mathematics demands proof. Let us see how the same discipline guides geometry. We begin again with observation. Each face of the pyramid forms a triangle. 3 angles, measured carefully.
We've measured several. They all add to 180 degrees.
That pattern leads to a conjecture. I suspect all triangles sum to 180 degrees. A conjecture is something we assume is true because we see a pattern, but it is not yet proved. If we want certainty, we must turn it into a hypothesis. Then we give it form. Wipe!
A hypothesis gives it logical form. If a figure is a triangle, then its angles sum to 180 degrees.
That is the condition.
Precisely. The condition must be met. The angles form a straight line. A straight line measures 180 degrees. So if it's a triangle, the total must be 180. Now we test whether the condition holds.
The reasoning holds at every step. A hypothesis stands. Then the conclusion follows.
Damn it! Just one more thing!
Jaden, in crime or in geometry, the path is the same. Observation, patterns, conjecture, hypothesis, testing, conclusion. Jaden, a conjecture predicts from patterns. A hypothesis sets a condition for proof. One begins suspicion, the other structures logic. President Lincoln, I wish to express my appreciation. Logic, when properly taught, strengthens the mind. Young man, continue to seek truth through reason. Live long and prosper. Thank you, sir. Logic serves all ages.
Yes, sir.
A conjecture predicts from patterns. A hypothesis sets a condition for proof. One begins suspicion, the other structures logic.
Mr. Lincoln, what is the converse of a conditional statement?
Jaden, it is formed by switching the hypothesis with the conclusion. If P, then Q becomes if Q, then P. However, beware. The converse of a true conditional statement is not always true. For example, if a law is just, then it deserves obedience.
I understand, sir. The converse is, if a law is obeyed, then it must be just, but there are unjust laws.
Indeed, my boy. Did you know that if Adrian Monk sees a monkey, then he smiles? Please do not say the converse of that conditional statement. You mean, if Adrian Monk smiles, then he sees a monkey. No! Jaden, give me an example of biconditional statements.
Mr. Lincoln, a promise is kept if and only if the action promised is performed.
Excellent. A precise example.
Thank you, sir.
Jaden, now give me a geometry example of a biconditional statement.
Mr. Lincoln, angle A and angle B are congruent if and only if they measure the same.
Now restate that geometry biconditional example.
If two angles measure the same, then they are congruent. And conversely, if two angles are congruent, they measure the same.
The witness claims he unlocked the study at precisely 9 o'clock. If the study was opened at 9, then this key was used. And if this key was used, then someone must have unlocked the study.
Yes, I unlocked it. In this case, the truth rested upon a relationship that worked in both directions. If the witness used the key, then the study was opened. And if the study was opened, then the key must have been used. Biconditional statements are the bedrock of logical equivalence. They assert that two propositions imply each other. This is true only when both are true or both are false. In geometry, to designate a biconditional statement, one uses the phrase if and only if. This asserts that the statement and its converse are both true, creating a logical equivalence between the two conditions. In geometry, a biconditional statement is true when both the conditional and its converse are true. For example, a shape is a rectangle if and only if it has 4 right angles. The statement and its converse are both valid. Jaden asks him what symbol is used in geometry for biconditional statements. The symbol is a double-headed arrow indicating if and only if. It conveys logical equivalence. A fellow from the Australia bush arrives, throws a double-headed spear into his desk, and asks, "You mean like this?" and then laughs.
G'day, mates! Where did you come from? I just got out of geometry class. We studied biconditional statements. The law of detachment is simple. If a general fact is true and a specific case fits it, then the conclusion is true.
An example, sir?
If all men are mortal and Socrates is a man, then Socrates is mortal.
I see.
Here is our rule. If a suspect's fingerprint is on the safe, then that suspect touched the safe. Okay, that makes sense. That's the rule. This means if P happens, then Q happens. In this case, if a suspect's fingerprint is on the safe, then he touched the safe. Cause and effect. That's the rule. The fingerprint on the safe belongs to Mr. Carter. This symbol represents that the fingerprint is on the safe. The condition is true, so P happened.
Therefore, key must be true. This final letter Q represents the conclusion. In logic, we place the symbol for therefore, the law of detachment.
The law of detachment is a key tool. It lets us draw a specific conclusion from a general rule. Let us call this statement P implies Q. It means that if two angles are vertical angles, then their measures are equal. So whenever that condition happens, equality follows. That connects the condition to the conclusion. We are told that these two angles are vertical angles. That means P is true. The condition has been satisfied. The first part of the rule holds. If P implies Q and P is true, then therefore Q must be true. The measures of the two angles are equal. That conclusion follows directly. The reasoning is complete. This arrow represents a rule. If the first statement is true, then the second statement must follow. So the arrow shows the direction of the rule. It connects condition to conclusion. We are told that the first statement is true. That means the condition has been satisfied. So the starting point is confirmed. The requirement holds. If the rule connects the first statement to the second and the first statement is true, then the conclusion must also be true. The dots show the conclusion follows. The reasoning is complete.
That symbol on the bottom stands for P, therefore Q.
Isn't that supposed to be 3 dots in the shape of a pyramid?
Do we have to be around all this countryside? It make my nervous. Watch out, here comes a bull!
Let me summarize. You start with an if-then statement, the condition and the conclusion. The if statement is the condition, hypothesis, or postulate which is assumed and needs to be tested. The then statement is the conclusion. A whole if-then statement is the general rule. The if or condition statement is symbolized by a letter P. The then or conclusion statement is symbolized by letter Q. The testing of the condition P is symbolized by an arrow pointing to the right, toward the conclusion or Q. So P arrow Q means if the condition testing, then the conclusion. Now look at the illustration. You see at the top a P arrow Q. This is the general rule we are investigating. Below that is a single P. That is the condition, postulate, or hypothesis which we need to confirm by testing. Is this true? Now look once more at the illustration. The third symbol is a letter P, followed by a symbol looking like 3 dots arranged in the shape of a triangle or pyramid, and then a letter Q. Jaden, those dots stand for the word therefore, so you would read this as P therefore Q. So after testing the condition and know that it is true, we know for certain that the conclusion is true. Finally, the law of detachment says that if the general rule is true and the condition or hypothesis is true, then the conclusion must be true. Here is an example. If a person is a man, then that person is mortal. The general rule is true because mankind always dies. I am a man, thus P is true, and so Q must be true. Therefore, I am mortal. P, therefore Q.
If P implies Q and Q implies R are both true, then P implies R is true. This is the chain rule, linking the implications. Therefore, P implies R is true. We start with the conditional, P implies Q, and the premise P, both marked true. The chain links them together to reveal the conclusion, Q is true.
The law of detachment is a key tool. It lets us draw a specific conclusion from a general rule. The law of syllogism builds on this, linking chains of logic together, foundation of clear, reasoned argument.
We begin with a general rule. If a man is human, then he is mortal. That is a universal statement. It applies without exception. Indeed. Now, consider a specific case. Socrates is a man. When the condition of the rule is satisfied, the conclusion must follow. Therefore, Socrates is mortal. This is known as the law of detachment. A true rule applied to a true case produces a necessary conclusion.
Well now, that sounds mighty philosophical. If mortality comes included with humanity, poor Socrates signed the contract without reading it.
Observe a second structure. If a man is human, then he is mortal. If a man is mortal, then he will eventually die. These statements connect. It follows that if a man is human, he will eventually die. This demonstrates the law of syllogism, one conditional linked to another. So first you qualify as human, then you qualify as mortal, and eventually you qualify as departed.
I suppose logic is thorough, if nothing
Thorough
else.
and inevitable. Death appears to be the one appointment that never consults a man's calendar.
Indeed, my friend.
I wonder where the term kick the bucket came from. They would place a bucket of holy water near the deceased, and the watchers would touch it from time to time. It seemed a practical arrangement, faith measured by the bucketful. I saw in the paper that you were pushing up daisies. Reports of my demise were sorely exaggerated. In the adventures of Tom Sawyer, Injun Joe is hiding inside the cave. If a man is inside a cave, then he must eventually leave through one of its exits. A logical deduction. If a man must leave through an exit, then sealing that exit confines the man. Judge Thatcher sealed the cave's main entrance. If Injun Joe is inside the cave and the entrance is sealed, then Injun Joe cannot escape. You have linked one conditional statement to another. When one truth leads directly to the next, the conclusion becomes unavoidable. That is the law of syllogism.